So this next unit that we're starting is factoring. There are a bunch of different types of factoring. The first one we're going to do is called GCF. I'm just going to start by asking, have you heard that before or know like what that stands for? GCF. If not, that's fine. I'm just not sure if you have. You may have not. It stands for greatest common factors. If you haven't heard of that, let's write that down. Greatest common factor. You're going to be okay.
Well done.
So this is distributing, but backwards. You are undistributing. You are factoring something out instead of multiplying it through. And the most important word out of that is not greatest, it is common. They have to have something in common. Can you take $10 from someone that only has 9? No. So they have to have whatever it is in common. So for your coefficients, it's going to be the largest number you can divide out. I'm going to show you, there are plenty of examples here. And also Desmos will do this part for you. It won't do the variables, but it'll do this part for you. And I'll show you in just a second. Largest number you can divide out. For the variables, listen, you're going to use the smallest exponent. And what I usually get asked is, Ms. Cole, why is it smallest exponent? You just said it's called greatest common factor. You can't take something from someone that doesn't have it. They have to have it in common. So whatever is the smallest one is what they're all going to share in common. Now that part you have to figure out yourself, but I think if I give you a list of numbers, you'd be able to figure out which one's the smallest. Calculator will do this part for you. If you type GCF and then parentheses with all the numbers, you put commas in them on Desmos, it'll do that part for you. And I'm going to share my screen and like give you an example. Let me bring up Desmos real quick. Don't share my screen. Let me just make up an example. So if you type, can you look? Because this is going to pretty much do the first part of the problem for you. If you type, I want the greatest common factor. Please stop that. Let's do, let me make one up. Listen, I'm making a problem up. Can you hold on? 16, are you listening? Say you had 16 and 24. What is the greatest common factor between 16 and 24? Before I type it, I want to see if anyone can tell me. What number can you divide out of both 16 and 24? And that's correct, it's 8. But watch this. Look, do you see that? How I just typed 16, 24 and it gave me the answer?
I see that.
8. Can you do this? Because that'll help you on your test. GCF and then just type the numbers in. Okay. So now we're going to go and actually like do some problems. Let's look at the first one. You have a 6 and you have a 30. What is the biggest number you could divide out of both 6 and 30?
6.
It's the biggest. So 3 is not wrong, but 6 is larger. So what you're going to do is put 6. Can I take an X from both of them? Why not? Because you're correct. I cannot. 30 doesn't have one and they have to have it in common. So I can't take out an X. So my GCF is 6. You're going to put some parentheses. And I'm going to write this out for the first few, but I want you to eventually be able to do this step without having to write it every single time. You're just going to divide them both by the greatest common factor. You're going to divide them both by 6. You are undistributing a 6. It is distribution, but backwards. All right. So what do you get for the first one? Just 1x plus, yeah, just x, and then 5. Can you look? Watch me point to this. If you were to distribute the 6 through there, do you see how you would get at 6x plus 30?
Yes.
We just did that in reverse. It's just backwards. And let's say you didn't know the GCF. Can you look at this real quick? If you type GCF 6, 30, it's going to tell you 6. So it will do that part for you. Yeah. Yay. All right, let's try another one. What can you divide out of both 10x squared and 30? 10. Anything else? Why can't you take an x or an x squared?
Because that's not a number.
Well, it's because 30 doesn't have it. Okay, so just 10. Well, 10 is bigger than 5. You want the biggest one possible. All right. Then you're going to divide these both by 10 and see what you have left. So 1x squared, good, minus 3. Do you see how if you distributed 10 through there, you would get what you started with? you would get 10x squared minus 30. We just did that backwards, right? Let's try it again. If these keep going smoothly, we'll get them all done pretty quick. What can you divide out of both 4 and 32?
4.
Good, 4. But if you didn't know, you would type in Desmos GCF 4 comma 32. It'll tell you 4. This needs to be a relevant question. Go ahead.
It's looking like the first time.
Well, oftentimes, yes, but not always, okay? The example I made up, remember how I said 16 and 24 and the GCF was 8? Okay, so it wasn't 16, it's not always. Now, there's actually something else you can take out here too. What else have they both got? X. Why can't I take 2 of them? This one has a squared.
Because they're both not squared.
Yeah, this one doesn't have a squared. It's the lowest one. They have to share it in common, all right? So put your parentheses, and you're going to divide both of these by 4x and just put what you have left. You are undistributing. I know you're paying attention, but can you write at least a couple of these down? All right. What's left from the first one?
X squared.
Just,
Squared.
well, this is an x squared, and we're dividing out an x. So 2 minus 1
X
is what? Just x
squared.
minus, what's left for this one?
-8.
-8. The x's canceled out. Listen, if you distributed the 4x back through there, you would get what you started with. Stop that. I need you to not confuse everybody else. All right. Look at number 4. Can you divide anything out of both 3 and 2? No. 1, but that doesn't help you. We don't do 1. That doesn't help us. All right. What else do they have in common? How many x's can we take? 2. Good. Perfect. Why can't you take 3?
Because the other one don't have 3.
Yeah, this one doesn't have 3. You can't take $3 from someone that only has $2, all right? Put your parentheses. You're going to divide these both by x squared. And then what's left? First one would be 3x, good, minus, and then just 2. The x squared's canceled.
Good job.
Yeah, good job. I'm going to do one more where I write this. After this, I'm going to try and have you do it without. I don't want you to have to write that every single time. You can, I guess, but all right, what can you divide out of these 2? Heads up. You can have a break when we're done here. 2 won't go into 3. What else can you take?
X and Y.
You can take an x, good. And you can take y. How many y's can you take?
2.
2, good, perfect. So put your parentheses. We're going to divide both of these by 3xy squared. So kind of a bigger greatest common factor. You can take a lot out of this. All right, so what's left in the first?
Y.
All right, well, the 3's cancel.
2.
The x's also cancel. So it would just be y. All right, the 3's cancel. You can put 1y if you want to. All right, plus, now look at this one. 6 divided by 3 is 2. Good job. What else is left there?
X.
X, because 2 minus 1 is 1. How about the y's? No, they cancel. Good job. Let's try it again. That's now on my recording. No one knows. All right, what can you divide out of 2, 14, and 16? 2, all right? You're doing a good job. Stay focused. We have 4 more problems here. Can you take any x's? No, why not? They don't all have x, all right? Now, all you're going to do is divide these all by 2. I'm not going to write it this time. I want to see if you can do it without me writing it. What's left if you divide these all by 2? Well, hold on. You got to do them in order. But what's the first one? You're correct on that one, but what's the first one? If you take the 2 out of that, 1 x squared, good, and then minus 7x plus 8, good job. If you were to distribute the 2 back through there, you would get what you started with. We're just doing it in reverse, all right? Good job. We got 3 more. You can do it. All right, what can you divide out of 5, 35, and 20? Good, it is 5, but look, if you didn't know, because some of those numbers are bigger, can I bring this up again? GCF, you would do 5, 35, 20. Do you see how, oh, except you got to type it correctly. Do you see how it says 5 right there? You with me? Okay, so we're going to put 5. Can I divide out anything else? No, good. So good, just an x squared, perfect. Plus 7x minus 4. Good job. We're getting there.
Yeah.
All right, you got 2 more. All right, you have 16, 12, and 24. You would maybe want to put this one into GCF. All right, what was the numbers? 16, comma, 12, comma, 24. Good. Did you say 4? Good job. All right, so 4 is our greatest common factor. Yes, go ahead. Okay, hold on. We're just not there yet. What else can you take out? X. Good. Oh, whoops. So we're going to divide them all by 4x. We're going to divide them all by 4x. So 16 divided by 4.
4x.
Good. Why is it squared? Because
Because there's
3 and then minus 1 is 2. Good. Plus, all right, now do the next one. 12 divided by 4.
3x.
3x. Good. You guys are getting it. Minus 6. Perfect. Hey, kind words only. Whatever, kind sounds only. All right. What can you divide out of both 5 and 14? 1, but that doesn't help us. I was about to pull up GCF, but you guys got that. And can I take any x's? Why not?
Wait, what is 14 of that?
14 doesn't have one. If there's nothing you can factor out, we call that prime. That is like your version of no solution, sort of. It just means we can't do anything to it. Okay? All right, so this next thing that we're going to look at leads into the second type of factoring that we're going to do. So we're not going to actually factor anything. We're just going to play this. Playing Xbox is what we call it. These little Xbox problems. Yes, sure. Okay. So I left some space here for us to talk about our positives and negatives. What you're trying to do is find numbers so that the top value is a product. What does product mean? Multiplication. And the bottom value is the sum. What does sum mean? Plus. Okay. So if your top number is positive and your bottom number is positive, that means both of your answers should be positive. Okay. So I made everything in the first row like that. So we're going to just try the first row. I'm going to show you a calculator trick, but I want you to try and do this without it first because this builds your number sense. You need to have some number sense to do this. Number sense is not something I can teach you. All right. That's just something you build through practice. Are you listening? Can you look up here too, please? It's a respect thing. You need to come up with 2 numbers that multiply together to be 18 and add up to be 9. Think about it. You want them to multiply to be 18 and add together to be 9.
2.
I need 2 numbers.
3
Do you know some numbers that multiply together to equal 18? 3 and 6 is correct. Do you guys see how 3 times 6 is 18, but 3 plus 6 is 9? Okay, we're going to try it again. This is not something I can really teach you. You have to have some number sense. You need 2 numbers that multiply together to equal 40 and add together to be 13. And that is correct. It's 8 and 5. Now I will show you a little calculator trick. Can you listen? This is the same thing we did back with the square roots. What was the number on top? 40? Do you see how if I type 40 divide by x, do you remember making the table like this? And then you can keep going until you find 2 of them that add up to be 13. Do you see that there? 8 and 5 would add up to be 13. All right. Like what's the next one on there? 28. So if I type 28 divided by x and make a table, now I'm looking for a pair of numbers that add up to be 16. Do you see it? Do you see 2 and 14 there?
Yes. Stop it.
Now 72 is kind of a bigger number. You might need the calculator for that one. Let me go and type that in. Are you looking? You have to look. All right. I'm going to type 72 divide x, make the table. Now we want a pair that adds up to be 17. So look through until you can find one. Are you guys looking? That adds up to be 17. You got to look up here to find it. Hello. Do you see a pair that adds up to be 17? 9 and 8 right there.
Good job, Gus.
Yep, good job. Now it's easy when they're all positive. Okay, let's do this. if the top number is positive and the bottom number is negative, you want two numbers that multiply to give you a positive, but add together to give you a negative. That means they would both be negative because a negative times a negative.
It's positive.
Is positive.
Plus negative.
Okay, good job. All right, so let's try these ones. You need two numbers that multiply to be 32, but add to be negative 12. So they'll both be negative. Well, 6 won't go into 32. Do you want me to make the table?
No.
You want to try and do it without the table? You need numbers that multiply to be 32. Oh, well, 4 is one of them. Here, let me make the table for you guys. We're gonna do 32. And don't ever put any
-4,
negatives.
-8.
There it is. Now, don't put negatives in the table, but do you see 4 and 8 there? 4 plus 8 is 12. We just want it to be negative 12. So -4 and -8. They multiply to be positive 32 because the negatives cancel. They add up to be negative 12. Let's try 60.
60.
You need numbers that multiply to be 60. I'll make the table for us. The table helps, all right? Don't ever type negatives into the table. Are you still with me over there, or do I need to fill out that form to have your phone taken? Because I will do that. You could actually be really good at this if you tried, all right? You need a pair that adds or subtracts up to be 17.
5 and 12.
Do you see 5 and 12 there? Okay, but when I write it on my paper, what am I gonna put? Good, nice job.
Nice the best.
Yes, but you need to be quiet, okay? So look at the next one, 44. What do you think of numbers that multiply to be 44? Good, but they are gonna be both negative. The negatives would cancel to multiply to be positive 44. Go and close your Chromebook. They add to be negative 15. All right, how about 10? You need numbers that multiply to be 10, but they will be -5 and -2. All right, for that next row, come back up here. If the top number is negative and the bottom number is positive, it means you're going to have one of each. But if your bottom number is positive, it means the bigger one is the positive one and the smaller one is the negative one. Because a positive and a negative, like if you wanted to add together to be positive, the bigger one is gonna have to be positive. You need to be quick, okay? So let's try -45. You need numbers that multiply to be 45. Just pretend it's positive 45. Do you know some numbers that multiply to be 45? Good. Now, which one gets the negative? If you want them to add up to be a positive 4. Good. 9 minus 5 is 4. Do you see how the bigger one's positive, the smaller one's negative? How about 14? Just pretend it's a positive 14. It would be 7 and 2. Which one gets the negative? Good. How about 30? You need numbers that multiply to be 30. Yeah, but 6 plus 5 isn't 7. And 6 minus 5 isn't 7. You need them to add or subtract to be 7.
Oh, wait.
10 and 3 is in. Which one gets the negative? Good. And then 24, you need numbers that multiply to be 24. Good. Which one gets the negative? All right, and then the last way this can turn out, if the top number is negative and the bottom number is negative. Again, it means you have one of each, but if you want them to add or subtract to give you a negative result, the bigger one needs to be negative and the smaller one needs to be positive. You want them to add up to give you a negative result. Okay, so let's try again. But again, you want to start out by just pretending everything's positive and get your numbers first and then worry about where the negatives go.
10 and 8.
All right, 10 times 8 is 80. Can you write it down too? All right. Which one gets the negative? Good, because -10 plus 8 gives you -2. All right, I need numbers that multiply to be 20. Just pretend it's positive 20. Just get the numbers first. Good. Get the values first, then decide what's negative. Which one gets the negative to get -5 plus 4 gives you -1. Good. You guys are getting the hang of it. All right, I just need numbers that multiply to be 21. Good. Then worry about which one gets the negative. Good. -7 plus 3 gives you -4. This last one's tricky. You need numbers that multiply. So is it the 2 and the 3 or is it the 6 and the 1? Well, I need one of them to be negative, but don't write this down. If I do 2 and 3, to get a -5, they'd have to both be negative, but a negative times a negative is a +6. So that's why that doesn't work. That happens a lot with the 6s and 5s. So you got to be careful with that one. So what was the other option? All right, 6 and 1, which one gets the negative? -6. Again, we didn't actually factor anything, but you have to be able to do this before you can do the type of factoring we're going to do.